Tommy and Gina, are you ready?
It's time for Maths with Mr. Thomas.
We are at the very end of the scientific notation chapter, and after learning everything and going over some past paper questions, I've put together a small review. This is just me going over the key points of the lessons. I'm not going over anything in a lot of detail. I'm not giving a lot of explanation. I'm not giving many questions or going over every slide. This is just for you to have a wee look at and check that you remember everything from scientific notation. If there's anything you have forgotten, if you want more of an explanation, if you want to see some questions, look back to the individual lessons. But as I said, just a quick recap of everything that we have done to hopefully help you before the exams. Does it help you? Well, hit the like if it does. So, we started off looking at what scientific notation was and converting to scientific notation. What was it again? It was just a way of writing really big numbers or small numbers. It was indeed, yeah. Rather than writing a number like this, which would take a long time to write down and be quite confusing to read, or a really small number, which again would take a bit of time or be confusing to read, you can write it using powers of 10. So instead of writing, for example, 5,000, you could write 5 times 10 to the power of 3. Or the 6,200,000, you could write it as 6.2 times 10 to the power of 6. Written like this, if it's a really big number with even more zeros, it makes it far easier to read. And the index shows you really how big or small the number is. We started off just with some numbers and we were writing them in scientific notation, and to do that we had to put the decimal point after the first digit that's not a zero, which you can see we have done for every single one of these, and then we counted how many places we had to move the decimal. For example, here we had 4.5 and then we would have to move the decimal twice to get to the end of the number. Or here it would be 1.88 and we would move the decimal 3 times, hence the 3. Or the 5.03 and then move the decimal 1, 2, 3, 4, 5 places. There were then a lot of questions on these for you to try, and if you want to see those questions, look back to this lesson, the first lesson in this chapter. But for those of you that managed to master that, we then went on to look at small numbers. If we had 0 point something, and if we did, we just did the exact same thing. We again put the decimal after the first number that's not a 0, and then listed the other numbers up until it was just zeros. So we'd have 4.16, and then we would have times 10 to the power of, and we looked at how many places we had to move the decimal. But because we moved the decimal back 3 places, the index became a negative. It did indeed. It's the same for each one of these. We had 6.7, and because we moved the decimal back 1, 2, 3, 4 places, we had -4. We did, yeah. It's the same for every single one of them. There were some questions for you to try, and if I remember correctly, you did really well with it. Yeah, go you. After that, we then went back from scientific notation just back to normal form. And the way we did that was we looked at the index, or the power. What that told us was how many places we had to really move this decimal. So because it is a positive number, we moved it to the right, and we moved the decimal 1, 2, 3 places, which means we had the 6, then the 2. So we wrote down the 6, then the 2, and because we had these 2 spaces, we filled it in with 2 zeros. Or with this one here, because there's a 5, we would move the decimal 1, 2, 3, 4, 5 places. So we had the 3, then the 8, then the 1. So we had the 3, then the 8, then the 1. And because there were 1, 2, 3 places, we filled those spaces in with 1, 2, 3 zeros. Again, if I remember correctly, you were amazing at it. Yes, I was. Awesome. We then had a negative index, and what was different about that? The decimal moved to the left, so we had 0 point. Brilliant. Yes, it did indeed. So if we had the -2, it meant we moved the decimal back 1, 2 places, so the decimal ended up here. So we had our 0 point, and then we had a space. So with the space, we filled the space in with a 0. Good. So we had 0.0, then the 9, then the 2, then the 1, then the 4. So we had 0.09214. You can see that for every single one of these. The -5 meant we moved the decimal back 1, 2, 3, 4, 5 places. So we had 0 point. And then because we had these 1, 2, 3, 4 spaces, we filled in 4 zeros before writing the 8, the 3 and the 3. We had more questions on that, which again, you were brilliant at. Awesome. And then we looked at using scientific notation on a calculator. Remember, as I was saying in the lesson, is that all the calculators are different. Some of them, a lot of them, use that times 10 to the power of button. Other ones, though, use this wee hat symbol just here, and other ones use that EXP. Learn how to answer these on your calculator. Don't just borrow a calculator every single period, because the chances are, when you get a question like this in the exam, the calculator might be different and the examiner cannot help you. Get your own calculator, learn how to use it, and then you can answer the questions using your calculator. So, we had some questions such as this. Work out 7.26 times 10 to the power of negative 6 divided by 4 times 10 to the power of 11. And if we're doing that on the calculator, you just type in the first part of your number. So we would type in 7.62. Then we would use our calculator to press one of the buttons. A lot of the time it's going to be the times 10 to the power of button. This button here. No. Other times we'd maybe use the EXP button. No. But then we would put in negative 6. Remember, a lot of the calculators, they use the positive negative button instead of the subtraction button. Try it in your calculator, see what works. Divided by, and in brackets, the 4 times 10 to the power of something. And then 11. Check on your calculator that you are getting this answer. If you're not getting this answer, you need to do something slightly different in your calculator. So work out what it is and remember that. There were other questions here, again, just using your calculator to answer the problem. The only thing that's slightly different, apart from using your calculator, is you have to work out, is it add, subtract, multiply, divide? What actually is it you're having to do? And sometimes what makes these questions easier is to imagine it's not a scientific notation number. Imagine that was just the number 2. Imagine if it said a spider weighs approximately 2 kilograms. A hummingbird's 18 times heavier. What's the weight of a hummingbird? Well, if it's 2 and it's 18 times heavier, you do 18 times 2. It's obviously not 2 though. It's 19.06 times 10 to the negative 5, but it's the same idea. You multiplied the 2 by the 18, but it's not 2, it's this number, so you still multiply this number by the 18. So to make these easier, sometimes forget about the scientific notation number and just put in the number 2 or 3 or 4 or 5 and work out what you would do. Is add, subtract, multiply, divide. If you do that, you will get a number. It'll probably appear this way on your calculator. You then have to write that in scientific notation. Hopefully that is easy enough. That's just what we did at the start. But make sure whenever you do these, you read the question. Because it says to give your answer to 2 significant figures, make sure you're giving your answer to 2 significant figures. Quick reminder, first number that is not a 0 is the first significant figure. Beside it is always the second. The second significant figure in this case here is in the first decimal place. So in other words, just round that number to 1 decimal place. Number after is a 3, so it stays as 3.4. So you have 3.4 times 10 to the power of, and then you've got the negative 3. Put in your units and make sure you've given your answer to so many significant figures if you're asked for it. Again, with this example, we just had to work out is add, subtract, multiply, divide. And once we worked that out, we just used our calculator for the scientific notation. And well, in this case, it was divide, so we just divided by 16. And we got our answer. It didn't ask in this one, but a lot of the time when you see this in the exam, you'll have noticed it in the exam questions, all the past paper questions, it often says give your answer in scientific notation / standard form. So I threw that in anyway, just for extra practice. Thank you. You are very welcome. Whee! Once we went over all those 3 lessons, we just applied all our knowledge to answer some of the past paper questions. These are the sort of things that they ask you in the exam. So ones that I went over in a lot of detail, explaining it. Again, look back to that individual lesson if you are wanting the explanation, if you want me to talk through it with you. But ones that pop up in the exam that people ask about to study supports an awful lot are the likes of this one. People ask about that one, about how that is done. I'll give you an explanation if you look at the lesson. Also this one here with the poppy seed and the sesame seed, that's one people ask about an awful lot. How do you do that one? And also this one. This is one with the pollen sample. That one is one of the ones that people ask about at study supports an awful lot. It seems to throw people. That's how it's done. If you want the explanation, look back to the past paper exam questions lesson. But if you're okay with that, that is the end of the review. And you may wish to either try some of the questions in the textbooks or just look back to some more past paper questions. As I said in the past paper video, there's probably more since this video has been made up. And I've not put in every single one of them. I've just tried to cover as many as possible. So that is a quick review for scientific notation. Hopefully it has helped. If it has helped you, give this a wee like, share it, tell your family, tell your friends, tell everybody. Bye.